Okay, today we are going to be talking about parallelograms. Parallelograms are a specific type of quadrilateral, meaning are four-sided. When we're thinking about our definition for a parallelogram, our definition is just a quadrilateral with both pairs of opposite sides parallel. And remember, parallel means that they're just two lines that will never cross each other. Our parallelograms will have some specific descriptions or specific characteristics that allow us to call them parallelograms. So we know that both pairs of opposite sides are parallel. So what we can do is put our arrows showing that they are parallel. Given that we have a parallelogram, we can also assume that opposite sides are congruent. So I can include those lovely tick marks. In addition to that, we can say that opposite angles are congruent. And we can also say that consecutive angles are supplementary. Meaning they add to 180 degrees. Another word for consecutive is same side. So in this case, these angles add to 180 degrees. These angles add to 180 degrees. So I believe that will be able to help you. We can also say that the diagonals bisect each other. So if we draw our diagonals in this shape, right, diagonals just divide the, are drawn just from angle to angle, we can say that this segment is congruent to this segment, and this segment is congruent to that segment. And our last conclusion is that one pair of opposite sides are parallel and congruent. So those are all of the characteristics that we can say about a parallelogram. We're going to be given different pieces of information and asked to make conclusions based on our knowledge of that. So let's start with some example problems here. Here we are asked to find FG and the measure of angle G. So let's first just start with FG. We know FG has a measure that is the same as the opposite side. So FG will have the same measure as HE. We're given the measure of HE, so I can automatically say that FG is 8. Now we're talking about angle measures. We know angle measures within our quadrilateral that opposite angles are congruent and same side angles are supplementary. So if we're asked to find the measure of angle G, we either need to know F or H. In that case, we don't, so we can just look directly across at the opposite angle. Angle G is congruent to angle E of 60 degrees. So the measure of angle G is 60 degrees. We found the measure of angle G by looking for the opposite angle measure. Okay. Let's take a look at this one. Now, we are asked to find x and y. We can just make some conclusions and set up an equation in order to solve for those angle measures, or side measures, I think, in this case. So here I like to just deal with my sides first. KJ has the same measure as LM because they're opposite each other. So the equation that we can set up is 18 equals y plus 3. Subtract 3 on both sides, and we get y is equal to 15. You can also always plug that back in and double check your work. Now to solve for the angle measure, we want to find out this angle here, J. We know J and L are opposite each other. J is congruent to angle L. So the equation that we will set up, again solving for x, we know J is 2x, we know L is 50. Divide both sides by 2, and we get x is equal to 25. So those are our opposite sides and opposite angles. Now let's find some additional measures within KJLM. Okay. So what we first want to find is the measure of NM, from M to N. What we know about our diagonals in our parallelogram is that diagonals bisect each other. So we can automatically put in tick marks to show congruence. We know KN will have the same measure as NM. So NM has the same measure as KN, which is 2. Now to find the entire measure of that figure, K to M is 2 plus 2, or 4. To find the measure of J to M to L, J to M to L, it's always helpful to highlight to see exactly what measure we're talking about. Now, I know that J to M to L is the consecutive angle to angle J. So, angle J plus angle M, which is just a shorthand version for J to M to L, adds to 180 degrees. So 110 plus the measure of angle M is equal to 180. Subtract 110 on both sides, and we get angle M is equal to 70 degrees. Now we want to find K to M to L, which is K to M to L. We know that this entire angle measure is 70 degrees. To find that smaller portion, we take 70 and subtract 30 from it to get 40 degrees. Again, some of these problems might be a little overwhelming due to the amount of things that you need to find, but that's where I find highlighting or just drawing in those measures is going to be really helpful for you to visualize. Okay, on to the back side. We are again talking about parallelograms. So let's look at some of these side measures. We are given FG is 5 and that KG is 3. In order to find JH, right, that's one of the sides of the parallelogram, I'm going to go specifically and directly across from that side to see if we have the measure. We do. FG has the same measure as JH of 5. So JH is 5. And my reasoning is just that opposite sides are congruent. I just use the shorthand version for opposite, saying up. Now to find JK. KJ is a portion of that diagonal. We are also given the rest of that portion of the diagonal. We know diagonals bisect each other, so those two parts are congruent. JK is 3 because diagonals bisect each other. Okay. For example 5, we're talking about a parallelogram. In this parallelogram, we're given that angle P is 70 degrees. I know that the angle opposite P also has to have that same measure, so I'm just going to mark it with a tick mark. And it just so happens that, yep, we are first finding the measure of angle R in this parallelogram. So angle R has a measure of 70. We know that opposite angles are congruent in a parallelogram. An additional piece of information is that we know angle Q and angle S have to have the same measure, but we don't know what angle Q or angle S is. So let's go to the angle directly next to angle Q. Angle Q and angle P, they add to 180 degrees. So what does angle Q have to be in order for Q and P to add to 180? So we do 180 minus 70 to get 110, because consecutive angles are sup, or they add to 180 degrees. Angle 6 is very similar to this. Angle 6, we're finding the value of x. Let's try to find some type of reason that we're able to talk about some type of measure with S and R. We know they're next to each other, so that they have to add to 180 degrees. So maybe we set up an equation to represent that. 3x plus 120 equals 180. We subtract 120 on both sides. We get 3x is equal to 60, or x is equal to 20. We can also go back and plug that in just to confirm. Okay, 3 times 20 is 60. 60 plus 120, yep, they add to 120 or 180 degrees, because those consecutive angles are supplementary.